The question is, suppose that for u and v in R3, we have the length of u is 1 and the length of v is 2. What are the largest and smallest possible values of the length of u minus v? So we've got two vectors in R3. They're length 1, they're length 2. We're interested in the length of the vector u minus v. I think a picture might be helpful, but I don't know how to draw vectors in R3. But well, it should be okay because I've only got two of them. And if I look at them in the right direction, they'd be in a plane. And that plane might as well be my page, so I can draw them on my page after all. So, let's draw them. This one is u, and it's got length 1. And this one is v, so it's v, and the length of v is 2. So let me see if I can draw u minus v on this picture. Well, if I interpret v as the point at the end of v and u as the point at the end of u, then u minus v would be initial point minus terminal point. So that's those 2 points there, and it would go from v to u. Sorry, terminal point minus initial point. So it would go from v to u because it's u minus v. So there's u minus v there, and we want to know how long that is. Well, we've got a triangle, and we know two of the lengths, and we want to figure out the other length. So if I knew the angle between those two sides, then I'd be able to figure out the opposite side. So let's call it theta. So let theta be the angle between u and v. Alright, so that means I can figure out that other side using the cos rule now. So the cos rule was c squared is a squared plus b squared minus 2ab cos c. So my c in this case is that vector u minus v, so the length of u minus v squared is equal to 1 squared plus 2 squared minus 2 times 1 times 2 times cos theta. And this is equal to 1 plus 4 minus 4 cos theta, which is 5 minus 4 cos theta. So now, in order to figure out the maximum and minimum values of the length of u minus v squared, I could figure out what the maximum and minimum values of cos theta are, and I know what they are. They're 1 and minus 1. So, the maximum value of cos theta is 1. So if I put 1 in there, I'll get 5 minus 4, which is minus 1, and that would actually be the minimum value of the length of u minus v, because of that minus would turn a maximum into a minimum. So the minimum value of the length of u minus v squared is 5 minus 4 times 1, which is 1. And therefore, the minimum value of the length of u minus v would be the square root of that. So, the minimum value of the length of u minus v is equal to 1. So we should be able to now figure out what the maximum value is by using the minimum value of cos. So the minimum value of cos is minus 1. Minimum value of cos theta is minus 1. So the maximum value of the length of u minus v squared is 5 plus 4, which is 9. And therefore, the maximum value of u minus v is, sorry about that, let's just rub out one of those lines. Okay, the maximum value of the length of u minus v is the square root of 9, which is 3. Okay, well that's the end of the answer, but I think I'd just like to convince myself that they really are those by drawing some pictures. And I can do that by just having a look at what the value of theta has to be in order to get those maximum and minimum values of cos theta. So, if theta was equal to 0, theta is equal to 0, well that would mean that cos theta would be 1. So, and also there's no angle between them. So there's u and v with no angle between them, and that's u minus v. So u is length 1 and v is length 2, so u minus v must be length 1 according to this picture, so that's good. Now the other extreme case when cos theta is minus 1 would mean that theta was equal to pi. So that would mean there's 180 degrees between them. So if u is here, then v is 180 degrees from there, which is here. And u minus v is here. So since u is length 1 and v is length 2, u minus v comes out to 3. So yes, I did get the answers right after all.